Hello, welcome to this video 1A.8. We're going to go ahead and talk about how to problem solve or how to utilize your calculator as a resource on some AP pre-calculus questions. So the calculator that I'm going to be using in this video is a TI-nspire. So if you have a TI-nspire, this video is for you. But some of the ideas are translatable. Will translate to other calculators too if you know how to use those calculators. Okay, so if you have a calculator, grab that, keep that handy. Okay, so in this lesson, we're going to go ahead and look at specifically how to evaluate a polynomial function in a calculator, how to graph a polynomial function, how to find some critical features and points on a polynomial function, such as extrema zeros, as well as the intersection of the two functions. For our notes here, and I'll just leave this here. If you don't have these notes, you can screencast or you can screenshot this. But here's kind of just the general how-to. If you ever get stuck on how did they do that? How do we do that? These notes are here for you, but I'm going to walk through all of these in these problems. All right, so let's go ahead and look at example number 1. It says, when given a polynomial function, f of x equals x cubed minus 2.81x squared minus 4.5x minus 16, answer the following questions. Determine all values of x where f of x is equal to 0, or state that none exist. So what I'm going to go ahead and do is I'm going to go to my calculator and I'm going to add a graph. I think adding a graph is one of the best things you can do in order to store a function. So I'm going to enter this function, so x cubed minus 2.81 x squared minus 4.5 x minus 16. Okay, I'm going to hit enter. And there is my graph. Now, I'm not completely sold on this graph. I want to remind you to change your window. I can't see much, so I'm going to zoom out. So again, menu, number 4, zoom out. I'm going to zoom out. I'm looking for zeros. I see 1, but I don't see the entire graph. Now that I see this, I feel better about this cubic function. So it looks like I have 1 real 0 and then maybe 2 imaginaries. And we want to find the zeros. So here's how you find some key features. All of these buttons are going to be underneath the Analyze Graph. So Menu, Analyze Graph, and you can see here 0. So I'm going to analyze this 0, and I get this value, 4.564. If you do not see this many digits, make sure you check your menu settings. So Menu, Settings, and then make sure that your float is on float or the highest float possible, okay? You'll want that to be there because you want at least 3 decimal places for your answer, okay? So our answer is x equals 4.564. That's where our 0 is, okay? B, find the values of x where f of x equals negative 3.8, or state that none exist. So what they want is they want the y value, or the outputs, to be equal to negative 3.8. So looking at this, negative 3.8 might be somewhere in here, but notice I can't find that exact x value. So what we're going to do is we're going to graph a secondary function. A couple of ways you can do this. You can double click on your current function, or you can just hit the tab button. If you hit the tab button, a secondary function will pop up, and we'll go ahead and graph negative 3.8, and I can see now I have this constant function, and I want the intersection. Where is the function equal to that? So we find that x value by clicking the intersection. So again, menu, Analyze Graph, intersection, and it says what's the lower bound. So you want to click a spot left of the intersection and right of the intersection when it asks for an upper bound. And this occurs at x equals 4.442 if we round. Okay, so there's our answer. C, find any relative maximums of f, or state that none exist. Okay, so we can go ahead and look at our graph, and right here it looks like I have a relative maximum here, and then the next question is relative minimum, so that occurs here. So I'm going to go ahead and go menu, and maybe you want to like zoom in. Maybe you want to zoom in. I'll show you this. Menu, window, there's a box tool, so I can click zoom box, and it says what's the first corner. Maybe I want to start here, and then I want just this, almost like you're snipping that portion of the graph. So now I'll go ahead and find my maximum. So analyze maximum. So again, left, right, and then here is my maximum. Okay, so a couple of notes about the question itself. I'm just going to jot down these two values really quickly and then show you how I'll answer this question. It says find any relative maximums. When they ask this question, they're wanting the y value. So I would say f has a max of, and I put the y value, and then I also like to include a secondary sentence that says at x equals. So this is the maximum, the relative maximum, negative 14.528, and that's where it occurs. Notice they're not asking for x values, so include the y value. And then part D here, it says find any relative minimums. Okay, so pause the video. I want you to try to go ahead and find the minimum and write a sentence, but I'll show you how I do this here. Okay, hopefully you paused and you gave it a go. Much similar to the last question, we're going to analyze the graph, but this time I want minimum, and the minimum occurs right here. So I'm going to click left and then right of it. So here is our values, negative 29.190 if I round, and this occurs at 2.479. So my sentence would look like this, is I would say f has a minimum of that value at x equals that value. All right. Let's go ahead and look at some questions now involving average rate of change and look at how we can use our calculator to help us answer these questions. So the function g is given by negative 0.5x squared minus 7.26x plus 2.41. What is the average rate of change of g on the interval 1 to 4? So what we're going to want to go ahead and do is again open up a new document, and what I'm going to do is I want to show you how to store functions in the calculator page. So here's a calculator page, and I'm going to go ahead and just type in that function, so negative 0.5x to the power of negative 0.5x to the power of 2 minus 7.26x plus 2.41. So I'm going to go ahead and I'm going to assign this a variable. So I've entered my function, and now in order to store the function, you can use the store button. So there's control, and then right above the VAR is store. So STO. By hitting this with the control on, I hit store, and you'll see the arrow, and I get to name it. So since this function is called g of x, I'll enter g, parentheses, x. Okay, and so now I hit enter, and it says done. And now I have the function g underneath VAR. So for this function, I want to find the average rate of change on the interval 1 to 4. So I need the y values at 1 and at 4. So I'm going to say, okay, what is g of 1? I hit enter, and then what is g? You could type it too. G of, and I want 4, and we get negative 34.63. Okay, so we can go ahead. We can set up average rate of change, right? So your average rate of change formula is g of 4 minus g of 1 over 4 minus 1. On the AP exam, you want to include this. This is called the difference quotient. So I'm going to include these values, and this is negative 34.63 minus a negative 5.35 over 4 minus 1. So again, here's your difference quotient, okay, and this is necessary to earn the point. And then we're just going to use our calculator to go ahead and compute this for us. So back to the calculator. I can enter difference quotient by control divide. So here's my fraction, and I can enter g of 4 minus g of 1. I could also punch in the values. I could type those values, 4 minus 1, or 4 minus, or just over 3. Hit enter, and then there is your average rate of change, negative 9.76. Okay. It's also important to note getting only 2 digits makes me a little weary. I like to see at least 3 digits, so just double check, make sure that your document settings here underneath that is at least at float 11, or if not a float, just to make sure you get all of your values there. Okay? All right, next question here. They say find the value of x where the graph of g changes from increasing to decreasing, or state that none exist. This is a graphical question, and this is why I love to graph functions to define them first. But since I defined it here, I just wanted to show you how to do that. I'm going to add a graph, and it's not too hard. I've already defined it as a function g, so I just enter g of x, and then now I have defined the function. Notice again I'm zoomed in, so I'm going to go ahead and zoom out here, and we have a quadratic function. And the question that we have is, where does it change from increasing to decreasing? And this occurs at a maximum. So I just have to analyze the maximum. Left, right, and there we go. Our answer is x equals negative 7.26. Okay. That's a 7. Next question. Here we go. Last one. Here we have a polynomial function h defined by h of t equals t cubed minus 7t squared plus 14t minus 8 for a restricted interval or domain. And this is very important. They say from 0 to 6. So again, what I'm going to do is I'm going to go open up a new document. I like to reset. I don't like to have lots of documents. And I'm going to graph this function. Something about this function is it's defined in terms of t. Notice the independent variable or the input is t and not x. Your calculator likes to define it in terms of x. So I'm just going to switch out the t's for x's when I punch this into the calculator. And we'll be able to graph it here. Plus 14. Oh, got to get out of the exponent. Plus 14x minus 8. And here's our function, okay? So they ask us here, on what intervals of t is the rate of change of h positive? Okay, well, that's going to start down here. Rate of change is positive. It's where it's increasing. And it's going to end right here. So where does this start? Where does my interval start? Well, it's actually not negative infinity. It's going to start at 0 because I have a restricted domain. And if you wanted to view that restricted domain, again, you could go to Menu, Window, and then adjust your window settings. Again, Menu, Window, my window settings, and I'll change my x minimum to 0. I only care about 0. And I only want to go to 6. That's what I care about. And then my minimum, you'd probably be fine, but I'll just add it. I'll make it negative 10 there. And we have a much clearer image, and you can see here our domain ends at 6. So this graph continues to increase. So, okay, so I start at 0, and then it stops increasing here at this maximum. So I got to go ahead and analyze the maximum, and that is 1.451. And then it's also going to start increasing too here at this minimum. Minimum on over, right? It's increasing. So I want to find that minimum, analyze minimum, left, right, okay, and I get 3.215. And then where does this interval end? Well, our domain ends at 6, okay, according to the prompt. So that's where I'm going to end it. Now, on what intervals of t is the rate of change negative? Well, my function's decreasing from max to min. So here our rate of change is negative. So that interval is going to be 1.451, comma 3.215. All right, C. What is the average rate of change between the absolute minimum and the absolute maximum of h? It's important to note that this graph here, visually we see the relative minimum or the local minimum and maximum given here. So here's our local extrema. Absolute is the biggest, and since our function is defined on a closed interval, our absolute minimum is going to be here at this function h of 0, and then up here, all the way up here for h of 6. Okay, so what I'm going to do is I'm going to go ahead and I'm going to find those endpoints, what they are, open up a calculator tab. I'm going to say, okay, what is the function value at 0 And what is the function value at 6? And there's the values. Again, I can just go ahead and write my difference quotient, right? So my average rate of change is equal to h of 6 minus h of 0 over 6 minus 0. You want to have a difference quotient, meaning I have a quotient and I have a difference in the numerator and the denominator. Okay, you have to show that. So I'll enter this, control divide, and we'll enter this, h of 6 minus h of 0 over 6. Oh, I don't have it defined as h. Whoops. Let me go up there, copy that down. It's not h. It's f1 of 6 minus f1 of 0. So you could use your keyboard too to type those in. Enter. And our answer, our average rate of change is 8. Okay, that's going to do it for this lesson. In this lesson, we talked about how to problem solve AP Calculus questions with a calculator. We specifically talked about how to use the calculator tab, how to store functions, store values. We talked about how to graph a function and then find key features of the graph, right? Max, min, zeros, as well as graphing a secondary function with an intersection. Okay, hope you liked the video. Give a thumbs up, especially if you use a TI-nspire. Subscribe. See you later.